Flipped Classroom video for Maths AS Unit 1, Surds. Rationality and absurdity. What is a surd? Well, technically, a surd is a number which can be expressed exactly only using the root sign. By exactly, we mean that they cannot be expressed as a fraction, or in other words, that they are irrational. For example, root 2 is a surd, cube root of 7 is a surd, 11 plus root 17 is a surd, 1 plus root 5 over 2 is a special surd. You might want to look into that. And you will prove the irrationality of surds such as the square root of 2 in A2. And often surd is used to denote irrational square roots only. And this is so for the rest of this video, and usually in your maths lessons that's what a surd will be referring to. So from the list above we'd often only use the word surd for root 2. And surds are not too difficult to handle, but they were for Hippasus, and he was a member of the Pythagorean school, and the legend or myth goes that he was executed for revealing that the Pythagorean school had discovered that there were irrational numbers, and this was seen as very shocking, and so he ran into problems. And it's a very interesting thing to think about the rational numbers, so that's fractions versus irrational numbers in mathematics, and the way we use that word compared to the way we use it in ordinary language, and also thinking about the words ratio and absurd. And all this sort of links into thinking about numbers as a whole. And so we have this Venn diagram of number sets. So we have the natural numbers, so the counting numbers, then the whole numbers, which includes 0, so that's a debatable point, but we have the integers, so that's the positive and negative whole numbers. Then we have rational numbers. We also have irrational numbers, and the rational and irrational numbers together with more numbers that are neither rational nor irrational make up the real numbers. And then bigger than that you've got the complex numbers, which you will look at if you study further maths. So numbers are not simple, but fortunately surds are not too difficult to handle, as I mentioned, so we'll have a look at them now. And one thing we need to do with surds is to simplify them. So if we look at basic surds, then what we're trying to do is simplify them to express them as simply as we can, and one motivation for that at least is to make things more understandable. So let's just have a look at an example to illustrate that. So the square root of 252. What we can notice with 252, or find out, is that it has a factor of 4. So that means the square root of 252 is the same as saying the square root of 4 times 63. Now we can separate that out into the square root of 4 times the square root of 63, and 63 factorizes into 9 times 7. So again we can separate that out into the square root of 4 times the square root of 9 times the square root of 7. And this separating out is essentially one of the things you've seen when looking at indices. So it's the same idea as if we have a times b to the power of half, we can say that's a to the power of a half times b to the power of a half. So once we've separated it, we know the square root of 4 is 2 and the square root of 9 is 3, so we can now write it as 2 times 3 times root 7, which gives us 6 root 7. Now sometimes we may want to go the other way. We may have a number expressed as something times a surd, and we may want to just have it as a surd without the timesing. And this time what we would say is that 3 can be expressed as the square root of 3 squared. And so we get square root of 3 squared times the square root of 11. We can then say that 3 squared is 9, of course, and then we can combine those two into the square root of 99. we might have a surd on the bottom of a fraction, and because division is much more difficult than multiplication to sort of work out or rough out, then it's worth not having surds on the bottom. So how do we deal with that? Well, there's a very neat trick, which is we times the top and the bottom of the fraction by the surd that's on the bottom, because then on the bottom we're going to get root 3 squared, and this idea comes up again later. So that means on the top we've got 2 times root 3, which is 2 root 3, and on the bottom we've got root 3 squared, which is just 3. So 2 over root 3 is equal to 2/3 of root 3, which is easier to grasp. There are also much more complicated situations to deal with, so we might have to multiply out some brackets involving surds, and we've got 3 root 5 plus root 15 times root 5 minus root 15, and we use the usual FOIL or whatever method you use. So first of all we're going to multiply the firsts together, so that's a 3 root 5 times root 5, and then the outside, which is 3 root 5 times minus root 15. That gives us, for 3 root 5 times root 5, we have 3 root 5 squared, and for 3 root 5 times minus root 15, we have minus 3 times root 5 times root 15. Then we have to do the end of FOIL, so we do the inner ones, root 15 times root 5, and the last ones, root 15 times minus root 15, and that gives us root 15 times root 5, take away root 15 squared. Now we've still got plenty of work to do, as you can imagine. So what do we get for the first term? Well, we know that root 5 squared is 5, so we're going to get 3 times 5 for that. For the next two, both of them have root 5 times root 15, so the first one of those middle ones is minus 3 of them, and the second one is plus 1, so overall we've got minus 2 of them. And we also can notice that root 15 is actually root of 5 times 3, and thinking of what we've just done on the other side of this page, you can see that we're going to be able to simplify that somewhat. Now for the last term we have root 15 squared, which is of course 15. Okay, so now we can see that we've got rather a nice thing that's happened, which is we've got 3 times 5 is 15 at the beginning of this, and we've got minus 15 at the end, so those two cancel out. So what we're left with is the middle term. We can see that we've got root 5 times 3, and we can separate the root 5 times 3 into root 5 times root 3, which means we've got root 5 times root 5 times root 3, and I've expressed that on the next line by root 5 squared times root 3, and of course we've still got our minus 2. Root 5 squared is 5, and we now can then multiply that together, and we get minus 10 from the 2 times 5, root 3. And in these questions I've shown different amounts of working out, and at first you may well want to do lots of lines of working out, and gradually you may speed that up and be able to see things more quickly and write them down more quickly. There's no perfect way of doing any of these, or correct way, so you'll find your own way by practice. Okay, I've already mentioned that we don't want surds on the bottom, and we've dealt with the situation where we just have a surd on its own, or a square root on its own on the bottom. But having surds in the denominator, as I mentioned, makes them more complicated to work out, and so we try to avoid this. And we may have surd as part of a reciprocal. The way we deal with this is that we use our old friend, the difference of two squares. So we'll have a quick reminder of that, not that you'll probably need it, but we can see how it works with square roots. So the difference of two squares is a plus b times a minus b is a squared minus b squared. Hopefully that's very familiar. And since the right hand side only has squares, we can use this to eliminate surds. So if, for example, we had a plus root b times a minus root b, that would give us a squared minus root b squared, which is a squared minus b. So on the right hand side, no surds. We could even have root a plus root b times root a minus root b, and that would give us root a squared minus root b squared, which is a minus b, and again, no surds. So let's see how this works with a couple of examples. We want to simplify 1 over 1 plus root 5 by not having any surds on the bottom. So you may be able to see that what we can do with the bottom of that is times it by 1 minus root 5. So that's using the difference of two squares. But if we do that, we have to times the top by 1 minus root 5 as well. So what do we get? Well, on the top we've just got 1 times 1 minus root 5. On the bottom we've got 1 squared minus root 5 squared. That is therefore 1 minus 5 on the bottom once we've squared those out, and that leaves us with 4 on the bottom. Well, actually minus 4. So what I've done is I've taken that minus up to the top, so the 1 on the top has become minus 1, the minus root 5 has become plus root 5, and that's left us with plus 4 on the bottom there. We could have 2 square roots on the bottom, 2 surds, and what we do here is what you might expect. Again, we're going to times the bottom by root 2 plus root 3, but if we times the bottom by that, we must times the top by that so that it's still the same fraction. And then on the top we've got 1 times root 2 plus root 3. On the bottom we have root 2 squared minus root 3 squared, and that means we've got root 2 plus root 3 over 2 minus 3, which is minus root 2 plus root 3, because the bottom of that fraction is just minus 1, so it makes the whole thing negative. And we could think a little bit there about, are we happy with that being negative? If we look at the original fraction, 1 over root 2 minus root 3, then we might think, well, root 3 is bigger than root 2, so root 2 minus root 3 will be negative. That means the whole fraction will be negative. So that can make us happy that we've ended up with a negative result. Obviously, you can also check all of this on a calculator. So, fractions of surds. Again, we may have surds in the numerator as well as the denominator. And in this case, we use what we've just seen to rationalize the denominator. When we say rationalize, we mean make rational, which means remove irrationality, which means remove surds in this situation. And while we're doing that, the numerator will take care of itself. And again, we'll have a couple of examples. So we have 2 plus 3 root 5 over 1 plus root 5, and we're going to times top and bottom by 1 minus root 5, which will rationalise the bottom of this fraction. With the top, we have got a quadratic basically. We've got 2 terms times by 2 terms, so we've got to be careful and make sure we go through the process there. So first we'll do the 2 times the second bracket, so that gives us 2 minus 2 root 5. And then we do the 3 root 5 times the second bracket, and that gives us plus 3 root 5 minus 3 times 5. And notice here I've taken a little shortcut because root 5 times root 5 is 5, and I've saved myself writing another line by just saying, well, that means we've got minus 3 times 5 there. On the bottom, of course, we're going to get our difference of two squares, so that's 1 times 1. Take away root 5 times root 5, which is in fact 1 minus 5. Now we can simplify the top. We've got 2 take away 3 minus 5 for the whole number, so that's minus 13. We've got minus 2 root 5 plus 3 root 5, so that's just root 5. And then on the bottom we've got minus 4. And then finally we don't want a negative on the bottom, so we times top and bottom by minus 1, which gives us 13 take away root 5 over 4 for our final answer. The second example is full of square roots. So we've got root 2 plus root 3 over root 2 minus root 3. We are again going to times, therefore, by root 2 plus root 3, which will rationalise the bottom of this fraction for us. And so we write that out like this. If we times the bottom by root 2 plus root 3, we must times the top by root 2 plus root 3. And then we can work our way through. So on the top, we've got the same thing squared. So it's a plus b squared effectively. So that's a squared plus 2ab plus b squared. which in this case is root 2 squared plus 2 root 2 root 3 plus root 3 squared. And then on the bottom we've got our difference of two squares happening, so we've got root 2 squared, take away root 3 squared. On the top, for the whole numbers, we've got our root 2 squared is 2. We've got 2 times root 2 times root 3 is 2 root 6. And because it's the root of 2 times 3. And then we've got plus root 3 squared, which is 3. On the bottom, we've got root 2 squared is 2. Take away root 3 squared is take away 3. And then on the bottom of this fraction, we have minus 1 again. On the top, we've got 2 plus 3 is 5, and we've got plus 2 root 6, but when we divide that by the minus 1 on the bottom, it makes everything negative. So we end up with minus 5 minus 2 root 6. And again, different amounts of working out, and as I said earlier, once you've practiced a fair bit, you'll settle into the best way of doing this for you.